Is that okay, right? All right. Uh, Today, I'm gonna keep the topic not just only land subsidence in Bangkok, but I think the thing that I would like to say today is that something really important for my country. Since we have a long time series of the data, I mean the satellite data, and then now it's become the SAR golden age in Thailand. You know, what's about the SAR golden age in Thailand? It means that SAR-based remote sensing for engineering, adventures, and the geophysical parameter estimation will become much more really important. So let's introduce myself. My name is ผู้ช่วยศาสตราจารย์ดรอนุเผ่าแพทย์ from Department of Civil Engineering, Faculty of Engineering เกษตรศาสตร์ University. Well, Sarkoden is, this is the word to express the currents and future SAR stream in the world during 2012. After the launch of Sentinel satellites, and then we really have, the free of charge of the SAR data, which in the past really expensive. And the basic discipline behind this is the ability of acquiring the data day and night and under all weather conditions. And, ease of mathematical equation, ease of multivariable equation of the microwave in the interferometric and polarimetric term. So this is, let's see what we are going to do. More than 10 years that I spent lots of time, working with InSAR. This is like Steve Jobs, said that to love what you do, right? This is, really the real love that I, work with the InSAR after my actually from my PhD. And then until now, I still, keep on going like wind, like wind. And you can see the past results of the InSAR for Bangkok Subsidence from 2005 until 2012, which is, at the time I tried to get the data. I used the RadarSat one, try to, continue doing the time series data. But after 2012, it's unluckily that we lost the data, the RadarSat one satellite, which is the Canadian based satellite. So after that, we have we have no time series that data from satellite. At the time of I made the publications about the using site interferometry in Bangkok area, and then I try to validate the data with leveling survey technique, which is really important. That we found that 80% of INSAR and agree with the leveling data. And then if you ask me for now, since 2018, as Femke already mentions about the continuing data, we don't have, leveling data anymore since 2018. So for now, I would inform you that only SAR that data that we still have available for the Bangkok area. This is the result from the last time, Geotech, the Geotech Song project, which is the conclusions of the project that we from my professor, Dr. Iti, the sea level rise and then land subsidence and then the tectonic drawdown, and then we simulate. This is, I think, we already mentioned about. We simulate the flooding area in the south of Chao River. And then after I quit the job at Chista and become the lecturer at the university, I and Department of Groundwater Resources, we are trying to establish the time series data for RadarSat 2 again. So remember, we don't have the radar set 1 anymore, right? But we're trying to do with the radar set 2. Why radar set 2? At the time, because we have like the radar set 2 data in our archive. So we try to uh, make the planning and then establish the time series data. But even we know at the time that we have, the Sentinel-1 data, but our knowledge, our model to work on the Sentinel-1 still, really difficult for uh, the people to do. But anyway, we got the result at the time. The substance still around, plus 35 millimeter per year, and then minus 34.2 millimeter per year. So this is actually is about the seasonal variations sometime. Yeah. And then now we are lucky that we have the collaboration project with UDEL, and then also Dr. Andy Hooper from University of Leeds, which is, we have a long time collaboration with the InSAR, and I really, gain a lot of knowledge from him. With the power of the processing at the University of Leeds, Dr. Andy and his colleagues produced a InSAR map from Sentinel-1 satellites. This is back to the years of 2014, if I remember. Yeah, and then until now, and then, but actually, the time series data still, uh, they keep going on collecting the data on our area. So I'm checking, and it's still fine for me. And then also I trying to, to process to do the time series data by our own, and then we also get the data from 2018 until 2012, and this is the initial result, as well as the result from University of Leeds. It is still the initial result, so we have to work more on that. And then for now, if take a look at back to the data gap here, I can conclude here that I think only 2013 and 2014 that we still have the data gap. But for from 2014, I think we can have the satellite data to process with no problem anymore. Well, we may try to use some satellite that they have the data archive at the time, maybe Terasat X or some other satellite. And with the Sentinel-1 satellite, we really, today we really lucky that we have the free of charge satellite to use for the application, like to study the land subsidence in our area, because we couldn't find any other scientific measurement to measure the, like, the very large coverage area, like using the satellite. And then you can check here that we have the Sentinel-1 and B, and if it's still kept going capturing the data in Bangkok area, and then we still have like time series data and monitoring for the long term. But anyway, something it is something that you have to take into account that this is not our satellite, right? This is not a Thailand satellite. So it's sometimes you have to think about it. And why monitoring using SAR? So we must understand the technique of scientific measurement. If applied in engineering practice, I'll bring down from scientific practice to engineering practice, and I'll point out to show you that how to do that. What it must be viewed from an engineering perspective, very important and sometimes very difficult to both sides understand each other. Then the space-based radar is really the advantage of this technique is the broad coverage and relative low cost, but even really expensive in the past. And for now, when we have the Sentinel-1 data available, everything can getting down like lower cost and easy to deploy and use for carrying other operation assets and see through the cloud and fog. As you know that in Thailand they're really tropical country, and then you can see the cloud cover all the time. So the SAR satellite can come to solve the problem. And then this is the very easy concept, right? The radar concept is just like the echo and the signal from the satellite sensor, is penetrate through the clouds and then hit the object in the earth, and then the signal go back to the receiver at the satellite sensor, and then you can easily see the very easy application like flooding application or something, because when the radar signal penetrate to the area that have the water, the signal cannot return to the satellite, and then it's become we call dark color in the SAR image. And then another thing that we have to consider about is that we have the data in both this ascending and descending orbit. So why is so important? It's important because sometimes you want to see the Earth, and then the look of the radar in both sides is different. So sometimes you have to think about, because the radar capture the signal not in the nadir direction, but they have to have like what we call slant range. They have to have the look angle, and then they can it's gonna capture the world. It's not the same as the optical sensor. And then, after if we use two image of the radar, the first image is, you capture the image before like the earthquake or some uh, event, some situation to make the earth move occur, and then you get the other image after that event, and then we try to process to see the phase difference, and this called differential InSAR using just only two image. But in Bangkok area, you cannot do that because you have to, you need the time series of the data. Only two image not enough for study the time series data and slow movement. Just only the big earthquake that we can use the differential InSAR and then get the good result. And then it's pretty concept. In the interface of radar, it contain many kind of phase error like topographic, ionosphere, them or baseline and noise error, and then they have deformation phase. So the model is we are trying to remove all other phase and then leave just only the formation phase, and then we get the result. However, if we like the information signal doesn't seem too strong enough, and then we can see nothing. If someone wants to try differential InSAR, they can use like the on demand. They can put the parameter, put the days, and then uh, this website from Alaska Satellite Facility, and then they can use the what we call the small baseline uh, criteria to choose the InSAR, the image pair for you to make the interferometry, and then you will wait just only 3 hours, and then you get the result of the InSAR data very easy. Just only press uh, 2 times, 3 times, and then you get the result. And this is what I have done with Dr. Paisan and Dr. Pasakon just last week. That we just try to do something, based on the earthquake, the Laos earthquake, 6.4 earthquake in Laos back to 22 November 2019. And then yeah, we just see something, but that's not enough because because we need the time series of the data. Using the differential only to time period, not enough. So for many years, I've been trying to expand my understanding of the technique in engineering. How to use the scientific data to in engineering field. So I think that we have to keep going on time series data, but it's sometimes very difficult. As I already showed you here, is that if we have done differential InSAR like landslides or earthquake applications, what we have done just only the in the beginning step. That's nothing. So we have to work on that using the time series with the technique, many kinds of technique available actually for the time series data like persistent scatters, short baseline or small baseline, or combine together. And we are lucky that we have working with Andy for a long time, and then we have the open source and free of charge software, and we can use it to process the data, and we can modify some parameter, and then whatever you want to do is about the processing. So it means that it's really different from using the website that belong to other agency, and then you can do nothing, just only press, and then you get the results, and then you cannot even translate the result. This is the example. When we get the data from this is back to what the year 2012, when the earthquake occurred in Nama, Myanmar, and then we got the data to one pair of the data before and after, and then we get the earthquake results like post-seismic or something, and then this is not enough. We have to work more on. We are trying to at the time uh, create the model and trying to see after that establish the time series, see the post-seismic what happening at the time in that area, and then calculate the Coulomb stretchings. Many more things that we have to work, as I already mentioned. This is just not just only have the data and then have the model and then trying to uh, process and then get the result, and after that you know nothing about. No, you still have a lot more to work on. So my question is that what more for Thailand taking benefit from SAR and INSAR? As I trying to explain a lot about the benefits of SAR data in Thailand. There's a lot more application that you can use for, and almost every day, and it's uh, a lot of things that you can do with the data, not just only having like using the optical and see the beautiful future picture of the earth when like when you watch in the Google Earth, but inside the radar signal, if you zoom in for the result of my past research, you can see some kind of what we call observation point. We have a lot of observation point, not only like 1000 and 2000 like leveling data, but we have uh, a lot more, like 200, uh, 200,000, more than 200,000. And if you zoom into that, you're gonna see you're gonna see the points uh, on top of the building or infrastructure. And then if we can clarify that, and then we can separate the observation point, which one is on the this building, which one is on that building, and then we can separate the subsidence rates of the from the sub observation point, and we can take benefit from that. We can study, we can use this for structural monitoring in the future, but it's just in the beginning. I'm just trying to learn about that. And then many paper publishes, and you can using my link to Google to see what they are doing. And even my past experience about using the radar, is one is radar set one, using for monitoring the coastal zone, the over the eastern inner Gulf of Thailand. And then we still have the good results on that. And then even outside our country, visit Myanmar, Yangpung, we still we are able to use the radar data and then trying to process and see what happening in that area. And then I'll take you to see what Netherlands have done so far, using taking the benefit from SAR data. The use is for subsidence monitoring, and then it kind of establish the service, and then using the satellite. I think it's many source of satellite. And then look at the other area like InSAR or the embankment dam in Norway. We can monitor the big structure. In China, they also have the time series InSAR for three short dam monitoring. And then this is the monitoring of dam in Iraq. And then also another application that we can do using InSAR, like um, the solution for oil and gas and mining. In many countries, they use the InSAR in many kind of applications, just like this. And then one of my research is to detect the offshore platform in Malaysia, in the cooperation with the University Technology of Petronas. And at the time, we use the Terasa X data to monitor the offshore platform. This work. And I think that, in our country, we can adopt this technology and then trying to apply to many applications. This is what we can do. Also, the mine monitoring, we can use the satellite also. And this is the overall, like if you want to use the satellite for surface asset monitoring, and then you have many kinds of measurement, and satellite or SAR satellite is one of the measurement. You may have some other measurement work together. Is okay. So here we come to the SAR golden age in Thailand. Survey engineering has entered the geodynamic era with the development of GNSS core station and the InSAR technique. So from the subsidence, many deformations can be measured using the same different technique. So we have to be more concerned about it. And the study of infrastructure health monitoring require more paradigm shift to analyze this. So it's still difficult. I know that, but we have to start now. And then, as I already mentioned, we have to use InSAR with other geodetic technique like GNSS and maybe corner reflector, which is really important to reflect the radar signal, and then you can see the bright in the image. In some country, you can see the satellite survey units just like this. So we may be applied in our country to monitor the infrastructure. And then the top 5 challenge in monitoring with InSAR. The first one is require regular monitoring. And the second one is the high cost of the data, but now not really high. But it depends on if you choose the really high resolution, like if you want to the data from Terasa X, which is really have high resolution, and then you have to pay more. And then the number 3, if you want to monitor like in the area really far away and there's not many building there, but you still can capture the image in that area with a good signal using the corner reflector. Then level of detail is coverage. Yes, the coverage area from inside is very good. But this is a trade-off between the resolution and the coverage. If you have the high coverage, and then your resolution will be lower. And then the lack of inside expertise. This is important in our country. I try to teach our student in Kasetsat University, and then we are still in the beginning of the thing. But anyway, this is important, and let's take a look back the olden time of science in Thailand. This is a 10 year that really have the adventure. Look back to the 2008 when I work at the Alaska Satellite Facility. I met Fran Meir, and then really many things happened at the time. This is just the really beginning. And then I got the second opportunity to work with him and many other nice people at Chulalongkorn University. Also with my professor, Dr. Iti Siri Satayawong, and Professor Ramon Hansen from TU Delft at the time. And then after later on, Dr. Andy come, and then we work closely with Dr. Andy up to now, and then really have a good memory on that. Also, Dr. Chalermchon as well in that project. We really have good time. And then I think this is all my presentation today. Thank you very much.